We will now solve problems using the concepts of force of friction. Let's start with this problem. When a horizontal force of 300 Newton is applied to a 75 kilogram crate, it slides on a level floor opposed by a force of kinetic friction of 95 Newton. What is the acceleration of the crate? What is the coefficient of kinetic friction between the crate and the floor? Well, let's picture the problem. Here is the crate that is sitting on the floor, and the mass of the crate is 75 kilogram. The weight of the crate, mg, is m times g, that is mass 75 kilogram times 9.8 meter per second squared, is 735 Newton, which will be acting vertically down. The normal force on the crate, Fn. Tell me, what is the normal force on the crate? The normal force will be opposite to this. So that will be the normal force, and that will be equal to 735 Newton. Alright, what are the other forces acting on the crate? So Fn equal to 735 Newton. A force F equal to 300 Newton is applied to the right. There you have a force of 300 Newton applied to the right. And now you have a frictional force between the crate and the floor. How much is the frictional force? That is 95 Newton. So since the crate is moving, the force of friction is kinetic, and it is given as 95 Newton. The force of kinetic friction is 95 Newton, and that will be opposing motion. Therefore, what is the net force on the crate? The applied force is 300 Newton. The force of kinetic friction opposing that is 95 Newton. Therefore, the net force is the applied force minus the force of kinetic friction, and that is 205 Newton. And you can see the vertical forces will not play a role in the motion here because they cancel each other. Okay, this net force produces an acceleration on this mass of 75 kilogram. So we have F net equal to ma. 205 Newton is the net force. That net force equal to 75 kilogram times A, and solve for A. That gives you A equal to 2.73 meter per second squared. Well, we found the acceleration. What is the next part we need to do? What is the coefficient of kinetic friction? Well, if you remember the definition of coefficient of friction, it is the frictional force divided by the normal force. Well, the force of kinetic friction is 95 Newton. The normal force is 735 Newton. And so we can now write Fk equal to mu k Fn. I have inadvertently used the uppercase F here. It's supposed to be the lowercase f. So the force of kinetic friction, lowercase fk. So make that change there. The force of kinetic friction is mu k times the normal force. That is mu k times mg. Therefore, mu k equal to Fk divided by mg, and Fk is 95 Newton, mg is 735 Newton, and that is 0.13. So you can see these kind of problems are fairly simple once you can picture it and put the forces in the right place. Okay, let's look at another problem. A stalled 1500 kilogram automobile is pushed towards a gas station by a man and a woman. The man applies a horizontal force of 335 Newton and the woman applies a horizontal force of 220 Newton. There is no gender discrimination here, just so happened. If there is an effective frictional force of 400 Newton on the car as it moves, what is its acceleration? Well, again, you can figure out the net force. There is the total force. What is the total applied force? 335 Newton that is applied by the man, plus 220 Newton that is applied by the woman. So the total force minus the effective frictional force, that is 400 Newton, that will be the net force. And the acceleration on the car is produced by that net force. Is that right? Okay. Now, once the car is moving, what combined force will keep it moving uniformly? Now, once the car is moving, to keep it moving uniformly, you need only overcome the friction. That means there is no need for an excess force. There will be no net force on the car. Alright, let's set it up. The total applied force is 335 Newton plus 220 Newton, that is 555 Newton. And the frictional force is 400 Newton. Therefore, the net force on the car now is 155 Newton. It is this net force that produces an acceleration on the car. What is the mass of the car? The mass of the car is 1500 kilogram. So the acceleration therefore is net force divided by the mass, that is 155 Newton divided by 1500 kilogram, that is 0.103 meter per second square. Alright, can you answer the second part without my help? Actually, I answered that for you. Once the car is moving, what force will keep it moving uniformly? So, once the car begins to move, to keep it moving uniformly, you need only overcome the friction, which is 400 Newton. That means the combined force need only be equal to that 400 Newton. Is that right? Yes. So once the car is in motion, they don't need to produce an acceleration on it. They need only keep it moving steadily. And in order to keep it moving steadily, the forces must be balanced. And the combined force therefore must be equal and opposite to the frictional force. That is, they need only apply a combined force of 400 Newton. So probably the man can keep on applying that 335 Newton and the woman can give a hand by applying about 65 Newton. Is that right? Okay, simple problem. Let's look at another problem. A 5 kilogram wooden block is placed on an adjustable wooden inclined plane. What is the angle of inclination above which the block will start to slide down the plane? You remember in the previous lecture I told you, at a particular angle, the mg sine theta down the plane will be exactly balancing the frictional force mu mg cos theta. Now, if the angle is greater than that, then it will begin to slide down. So you need to find that critical angle. Well, that angle, if you remember, is such that the coefficient of friction will be equal to tangent of the angle theta. So what is the angle of inclination above which the block will begin to slide down? At what angle of incline will the block then slide down the plane at a constant speed? Coefficient of static friction between the surfaces is 0.58 and the coefficient of kinetic friction mu k equal to 0.4. Well, if you understand the concept, this problem is very simple, because when the object just begins to slide down, the angle will be such that tan theta equal to mu s. And now, once the object begins to slide down, to keep it moving, you can actually decrease the angle, because you don't need the same amount of force to keep it moving. And so the angle at which you can keep it moving with a constant speed will be such that the tangent of that angle will then be the coefficient of kinetic friction. Well, let's put that down. Here is the block placed on the inclined plane. The mass of the block is 5 kilogram, and therefore its weight will be 5 times 9.8, that is 49 Newton acting vertically down. The component of the weight down the plane is 49 sine theta. Is that right? 49 sine theta. We don't know the angle. Now, the component of the weight pressing on the incline, the normal force, is 49 cos theta. The normal force Fn balances this force. So Fn is the same, which is 49 cos theta. And now, what is the frictional force acting up the plane? Do you remember that force? Fs equal to mu s mg cos theta. In other words, the force of static friction is mu s times Fn, mu s times 49 cos theta. So that is the normal force, Fn equal to 49 cos theta. Now, just before the block begins to slide down, the force of static friction Fs acting up will be Fs equal to mu s times 49 cos theta. You see that? This is the maximum frictional force. That means just when the block is ready to move down, this will be the force of limiting friction, the static friction, and that will be mu s times 49 cos theta. Well, at the instant when the block begins to slide, the downward force pulling the block down, which is 49 sine theta, is balanced exactly by the force of static friction acting up the plane, that is mu s 49 cos theta. There you are. We have actually done this before. So 49 sine theta equal to mu s 49 cos theta. Therefore, mu s equal to sine theta divided by cos theta equal to tan theta. In fact, I actually repeated that whole process for you to solve this problem. You can actually start here and say, when the block begins to slide down, the angle theta is such that tan theta equal to coefficient of static friction. That would be enough. And therefore, 0.58 equal to tan theta, or theta equal to tan inverse of 0.58, that will be 30 degrees. And now, the B part, when the block is sliding down with uniform velocity, what will be the angle? So when the block slides down the incline at a constant velocity, let the angle be alpha. Will that angle alpha be, will that angle be greater or smaller than the angle we calculated earlier. Will be smaller because to keep the object moving uniformly, you need only a less amount of force. That means the angle can now be smaller. And let that angle be alpha. The net force on the block now is 0. That means the force of friction Fk, the force of friction now is no longer Fs, but it is Fk, which is less than Fs. And that's the reason why the downward force now need only to be less than the previous case. And that's the reason why the angle can now be smaller. So Fk equal to mu k mg cos alpha, mu k times 49 cos alpha. That is the force now acting up the plane. And that force equal to 49 sine alpha. And that is when the forces are balanced. And that is when the object will be moving with uniform velocity. Now, solving from mu k gives you mu k equal to tangent of that angle. So alpha will be therefore tan inverse of mu k. Alpha is tan inverse of 0.4. That is 21.8 degrees. So if when the angle is 30 degrees, the block begins to slide down. In order to keep it moving with a uniform speed, you can decrease the angle to 21.8 degrees. Okay, let's now look at another problem. While being unloaded from an airplane, a 20 kilogram suitcase is placed on a ramp inclined at 37 degrees. When released from rest, the suitcase accelerates down the ramp at 0.25 meter per second squared. What is the coefficient of kinetic friction between the suitcase and the ramp? Well, we have now an inclined plane again, so let's make a picture of that. This is a suitcase on the ramp inclined at an angle of 37 degrees. The mass of the suitcase is 20 kilogram. That means its weight will be 20 times 9.8, 196 Newton acting vertically down. Now always do these preliminary steps, because the more number of times you do it, the better you learn these concepts. So mg equal to 196 Newton acts vertically down on the suitcase. The force pulling the case down the ramp, the force pulling the case down the ramp will be mg sine 37. That is 196 sine 37. That is 118 Newton. So the force that is pulling the suitcase down the ramp is 118 Newton. What is the force of friction? Since the suitcase is sliding down, the force of friction is the force of kinetic friction. So Fk equal to mu k mg cos theta. Alright? Fk equal to mu k mg cos 37 degrees. And that will be mu k times 196 cos 37. We don't know mu k, do we? No. Therefore, we will leave it as it is. And 196 cos 37 is 156.5. So the frictional force Fk equal to 156.5 mu k, and that will be opposing the downward motion of the suitcase. That will be the upward force. Fk equal to 156.5 mu k. Therefore, what is the net force on the suitcase? The net force on the suitcase is the downward force 118 minus the frictional force 156 mu k. And it is this net force that produces this acceleration on the suitcase of mass 20 kilogram. So we can now say the net force equal to MA. Alright, let's do that. F net equal to MA, and that is 118 minus 156 mu k. This is F net equal to MA, mass is 20 kilogram, acceleration is 0.25, and this 20 multiplied by 0.25 is 5. So our equation now is 118 minus 156 mu k equal to 5, and the only unknown there is mu k, which you can calculate. So 156 mu k equal to, take it to the right side, will be 118 minus 5, that is 113. Therefore mu k is 113 divided by 156, that is 0.72. That is the coefficient of kinetic friction between the suitcase and the ram. Alright, let's now do another problem. A 3 kilogram box resting on a horizontal shelf is attached to a 2 kilogram box by a light string as in the figure. There you are. A 3 kilogram box sitting on a horizontal shelf is attached to a 2 kilogram box by a light string that passes over a pulley. What is the minimum coefficient of static friction such that the objects remain at rest? In fact, what is the coefficient of friction between the surfaces such that the frictional force opposing motion will be exactly balancing the tension force pulling the object to the right? That is what we need to find. You know that the frictional force will be the frictional force will be, what is that? Fs, force of static friction, will be mu s Fn. Is that right? Alright, let's write that down. Well, let's consider the forces on the 3 kilogram box. What are the forces on the 3 kilogram box? Now, the weight of the box mg equal to 29.4 will be acting vertically down. And the normal force Fn will be acting vertically up. Now, they cancel each other. They really don't play a role in the motion of that box, does it? No. But you need them because we need the normal force to calculate the frictional force. So, the two vertical forces acting on the box are the weight 29.4 acting vertically down, and the normal force Fn, which is equal to 29.4. The tension T on the string will be pulling the box to the right. So here is the tension T that is pulling the box to the right. And what other force is there on the box? The other force is the force of friction. The force of static friction to the left, such that Fs equal to mu s Fn. And you know the value of Fn. Fn is 29.4. So that Fs equal to mu s Fn, that is 29.4 times mu s. We need to find the minimum value of this mu s. Well, mu s has a minimum value when the forces acting on that object are balanced. The force acting to the right, which is the tension force, is balanced by the force acting opposite to that, which is the force of static friction, 29.4 mu s. Okay. Now, the minimum value of mu s should produce enough frictional force to the left to balance that tension force. Is that right? So the value of mu will be minimum under this condition. Under what condition? T minus Fs equal to 0 or T equal to Fs. So Fs in that state will be equal to T, or 29.4 mu s equal to T. Now, there are two unknown quantities there, so we will leave it there as equation 1. Well, we need another equation to solve that. Where are we going to get that equation from? Well, that equation is going to be obtained by considering the forces on the 2 kilogram. Let's now consider the forces acting on the 2 kilogram mass. Can you tell me what those forces are? Well, the weight of the 2 kilogram will be acting vertically down, and the tension will be acting vertically up. And because the pulley is frictionless and the same string passes over it, the tension forces will be the same. Is that right? The weight of the 2 kilogram, 2 times 9.8 is 19.6, is acting down over here. The tension T on the string will be acting vertically up. There is the tension T acting vertically up. And now, when the system is balanced, it is not moving yet. That means the system is balanced. Now, when the forces on this are balanced, 19.6 Newton must be equal to T. Is that right? Since the system is not accelerating, these two forces must be balanced, or we have T minus 19.6 equal to 0, or T equal to 19.6. Well, once you have the value of T, you can now take it to the equation 1 and calculate the value of mu s. So using this value of T in equation 1, we have 29.4 mu s equal to T, which is 19.6. Therefore, what is mu s? Mu s is 19.6 divided by 29.4, that is 0.68. Okay. Now, what else do we need to find? When the box begins to move, the friction opposing motion is the force of kinetic friction F sub k. Alright? When the box begins to move, the force that is opposing motion is no longer the static friction, but the kinetic friction, that is F sub k. There you are. So F sub k equal to mu k Fn, and mu k is given to us. That will be 0.3 times 29.4, that is 8.82 Newton. Well, if T is the new tension on the string, then the net force pulling the box to the right will be F net equal to T minus 8.82. That will be, well, this will be the net force, and this net force will produce an acceleration on that mass such that F net equal to ma. So T minus 8.82 will be equal to mass, that is 3 kilogram, times its acceleration. And we have another equation, T minus 8.82 equal to 3a. And we need to calculate the acceleration and the tension on the string. Now, what is the net force now on the 2 kilogram? You notice that the tension on the string is not the same as the tension in the previous case. Because when the system begins to move, the forces have changed. Therefore, the tension force will change. So we cannot use this T to be equal to the one which we solved in part A. The tension T will be different. Now, what are the forces now acting on the 2 kilogram? Well, the 19.6 will be acting vertically down, and the tension force will be acting vertically up. But the system is now moving down. That means there is a net force. What is that net force? That net force will be 19.6 minus that T. So F net equal to 19.6 minus T, and that net force must be equal to mass times acceleration of that mass. Now you have two equations. The first one is T minus 8.82 equal to 3A. The second equation is 19.6 minus T equal to 2A. Can you solve these two equations quickly? Well, rearranging this, actually you don't need to rearrange this. Do you know, if you add equation 2 to equation 3, can you add equation 2 and equation 3? Add the left hand sides. When you do that, the negative T will cancel with the positive T. In other words, we will get 19.6 minus 8.82 will be 2A plus 3A, that is 5A. And you can calculate A right away. Well, let's go this way. Rearrange equation 1. T minus 3A equal to 8.82. And this equation, when you rearrange, take the negative 2 to the right side. It will become T plus 2A equal to 19.6. And you can solve these two equations without any trouble. Well, this time, let's subtract the top equation from the bottom. Now look at the way I'm going to subtract. T minus T is 0, so the T's will go. 2A minus negative 3A is 2A plus 3A, that is 8A, equal to 19.6 plus 8.82. So you have 5A, is that right? 5A equal to 19.6 minus 8.82, and you can calculate A from there. And solving gives you T equal to 15.3 Newton and A equal to 21.6 meter per second squared. Now this is a very important type of problem, and it'll be useful that you learn how to solve these problems. Okay, let's move on to the next problem. Well, we need to complete that problem. The question is, once you calculate the acceleration, we need to know how long will it take for this object to reach the ground. The 2 kilogram mass has an acceleration of 2.16 meter per second squared. We just calculated the previous slide. The negative sign indicates that it is downward. So you need to now use the value A equal to negative 2.16 meter per second squared. So this mass is moving down with an acceleration A equal to 2.16 meter per second squared. And we need to find the time taken for it to fall through a height of 2 meters. Well, I haven't carried the whole of that question, so you need to go back and refer to that question. We need to find the time taken by this mass to fall through a height of 2 meters. Well, now that you know the acceleration is negative 2.16 meter per second squared. And y equal to 0 is at 2 meters below where the mass is. So we need to find the time taken for this mass to drop through 2 meters with an acceleration A equal to negative 2.16 meter per second squared. Can you tell me how to do this problem? What is the time taken by an object to drop through a certain height? The initial velocity here is 0. The initial velocity is 0 and it drops through a height y0. What is the equation that will help you to find that time? Well, we know y0. We assume that this is, well, initially the initial velocity of the object is 0. v0 is 0. We are looking for the time taken by the 2 kilogram mass to fall to the ground. That means the time taken for the y position to become 0. Is that right? This is the ground. Now, this is y0 equal to 2. We need to find the time taken for that y position to become 0. So that obviously you need to write down the position function. What is the position function for this object? Y equal to y0 plus v0t plus 1/2 at squared. Now here we need to find the value of this t when this y becomes 0. And you know y0 is 2 meter, v0 is 0, and so all you need to do is set this y equal to 0, replace y0 by 2, and use the value of a. What is the value of a? A is negative 2.16 meter per second squared, and solve for the time. So 0 equal to 2 plus 0 plus 1/2. A is negative 2.16 t squared. Now that will be, you can see, this will become 2 minus, what is 1/2 of 2.16? 1/2 of 2.16 is 1.08. So this will be 2 minus because of this negative sign. 2 minus 1.08 t squared equal to 0, or 1.08 t squared equal to 2. And therefore t squared equal to 2 divided by 1.08, that is 1.85 seconds squared, or t equal to 1.4 second. So under these conditions, when the system begins to move, it will take 1.4 second for the 2 kilogram object to drop to the ground. Now, another very important type of problem, and I want you to practice this problem one more time. All right? Another one. An automobile is going up a grade of 15 degrees at a speed of 30 meter per second. The coefficient of static friction between the tires and the road is 0.7. What minimum distance does it take to stop the car? B. What minimum distance it would take to stop the car if it were going down the grade? Now, what is the difference between the car going up the grade and the car going down the grade? Well, there is a big difference there, and I want you to be very clear about it. Now tell me, when the car goes up the grade, what are the forces acting on it? Now, when the car is moving up the grade, what is the direction of the frictional force? The frictional force will be down the grade. So, the forces acting on it are mg sine theta, that is the component of the weight pulling it down, and the force of static friction, which will be mu s mg cos theta. I hope you are now familiar with these. The frictional force, the force of static friction will be mu s mg cos theta. So when the car is moving up the grade, the forces that opposes motion is mg sine theta, that is pulling the car down, and the frictional force that is opposing the motion. Now these two forces are the net force on the car which produces the acceleration. We can therefore find the acceleration, which will be a negative acceleration. And once you have the acceleration, we can find the time taken by the car to stop in a certain distance. Is that right? Okay. Now, when the car is going down the grade, what are the forces now on the car? The difference is, when the car is going down the grade, mg sine theta is always down the grade. But when the car is moving down, the frictional force will now be up the plane. So when the car is now moving down, mg sine theta is down the grade. Mu k mg cos theta, which is the frictional force, will be acting up the plane. And the net force therefore will be, the net force will be the frictional force minus mg sine theta. It is that net force that stops the car. Well, here we assume that the frictional force is greater. Otherwise the car will never come to a stop. Is that right? And therefore, in the case when the car is moving up the grade, the net force trying to stop the car, or the net force that produces the negative acceleration on the car, is mg sine theta plus mu k mg cos theta. And when the car is going down the grade, the net force producing the acceleration on it is mu k mg cos theta minus mg sine theta. Alright, let's now write that down. So what are we looking for in this problem? We are looking for the minimum distance it takes to stop the car while it is going up the grade, and the minimum distance it takes to stop the car while it is going down the grade. Okay, now here is the road and the car is going up the grade. Theta equal to 15 degrees. V0, the car is going at 30 meters per second when its engine just goes off. Is that right? We are not using the brakes. We are using the force of friction. Now, we need to bring the velocity to 0. With an initial velocity 30 meters per second, we need to bring the final velocity to 0. And you know mu s equal to 0.7. Those are the data that we know. So the car is going up the plane. Is that right? I want to run the car one more time. The car is going up the plane. You need to know how far will it go. What is the distance it will go up the plane before it stops. When it is here, its speed is 30 meters per second. And you know what are the forces acting on it. So the weight mg of the car is acting vertically down. That's the usual routine that we do. Mg sine 15 degrees will pull the car down the plane. So what is the force pulling the car down the plane? Mg sine 15 degrees, that will be, we don't know the mass of the car, but g sine 15 degrees is 2.54. So the force that is pulling the car down the plane is 2.54 m, where m is the mass of the car. Alright, so this is 2.54 m. Okay, and mg cos theta is the normal force, and that will be equal to Fn. When the car goes up the grade, when the car is going up the grade, what is the direction of the frictional force we said? It is down the grade. And what is that frictional force? Fs equal to mu s mg cos theta. Now, mu s is known, we know that is 0.7, and so multiply 0.7 with g cos 15 degrees, and that will give you 6.6. So watch here again, the 6.6 is this mu s, which is 0.7 times 9.8 times cos 15. Now please check that on your own. 0.7 times 9.8 times cos 15 degrees is 6.6. That means Fs is 6.6 m. We don't know the mass of the car, so we leave it as such. The frictional force Fs is 6.6 m. And what is the direction of that frictional force? It is down the grade because the car is going up. So Fs equal to mu s mg cos theta, which is equal to 6.6 m. Alright, now what minimum distance does it take to stop the car? We need to find the acceleration of the car using the net force. The net force on the car is the sum of these two forces. The total force pulling the car down the plane, trying to stop it, is 2.54 m plus 6.6 m. That will be 9.14 m. And this net force will produce a downward acceleration of negative a. The acceleration is negative because it is opposite to the direction of motion. So that net force equal to ma. You see that? The net force on the car is 9.14 m. That net force produces an acceleration negative a on the car. Negative acceleration, downward acceleration, such that 9.14 m equal to negative ma. Now we don't need the mass of the car, it cancels from both sides. And that gives you directly a equal to negative 1.14 meter per second squared. That is the acceleration of the car downward. And now we can use these values. V0 equal to 30 meter per second. The final velocity v has to be 0. The acceleration is negative 9.14 meter per second squared. The question is, what is the distance the car will travel before coming to a stop under these conditions? Tell me, what is the equation we are going to use? We know the initial velocity, we know the final velocity, we know the acceleration, we need to find the displacement. What is the equation that is connecting all these quantities? Well, if d is the distance the car moves up so that the velocity becomes 0, then v squared equal to v0 squared plus 2ad. Well, normally we call it v squared or vf squared equal to v0 squared plus 2ax if the motion is in the x direction, or 2ay if it is in the y direction. Since the direction of motion is not x or y, we simply call that distance d. So v squared equal to v0 squared plus 2ad. Well, we know all these values. V will be 0. V0 is 30 meter per second. Acceleration we just calculated as negative 9.14 meter per second squared. Therefore, we can solve for d. So, 0 equal to 30 squared plus 2 times negative 9.14d. And solving for d gives you d equal to 49.2 meter. the car will come to a stop at a distance of 49.2 meter. Okay, let's now do the B part. What is the B part? If the car is now rolling down the grade, it has an initial velocity 30 meters per second, final velocity will be 0. What is the distance the car will roll down before it stops? That is what we need to find. Well, when the car moves down the grade, the force mg sine theta will be acting down the grade, and mg sine theta is 2.54 m, the same value that we calculated earlier. But the force of static friction now will be opposing the motion, and we calculated that again in the previous slide, that is 6.63 m. So that's the difference now. The car is moving down. The V0 is 30 meters per second down. The force of friction opposing the motion is 6.63 m, which is mu s mg cos theta. So the net force on the car now is mg sine theta minus mu s mg cos theta. And what is that equal to? 2.54 m minus 6.63 m. mg sine theta we calculated earlier is 2.54 m. Mu s mg cos theta is 6.63 m. And that will be, how much is it? And that is negative 4.1 m. The net force on the car is opposite to the direction of motion, and that is the reason why it is going to come to a stop. And this net force is going to produce an acceleration on the car of mass m. F net equal to ma. We can now calculate the acceleration. So F net negative 4.1 m equal to ma, and m will cancel, giving us the acceleration is negative 4.1 meter per second squared. And to find the distance it travels before it stops, we can use the same equation. What's the equation? If d is the distance the car moves down the plane so that v becomes 0, then v squared equal to v0 squared plus 2ad, and again v will be 0, v0 is 30, a, the acceleration is negative 4.1 meter per second squared, and using those values we can now calculate d, and d equal to 109.8 meter. Okay, I hope you are comfortable with the arguments that we are using in solving these problems. Well, I'm going to stop now. We have done enough number of problems in force of friction, and there is one more lesson in this unit before you are ready for your test 2. I hope you are doing your homeworks regularly. You see, the only way to learn a course like this well is to do all the assigned homework, and make sure that you do them and get back to me if you need any explanations. Alright, I'll see you for next lesson. That will be on circular motion. I will see you for that shortly.